Hello viewers, welcome to this video on probability tests. This video is being presented by the Postgraduate and Research Department of Physics of National College Trichy. Both the department and the college feel happy in sharing this video as an e-learning resource to the aspirants of these prestigious examinations. This is Dr. T.V. Sundar explaining you the solutions to the problems that are going to be discussed and the related concepts in this video. You know that probability is one important concept of mathematics that is being taught to students high school level. Why these probability concept questions are being asked in many competitive examinations? Actually, the concept of probability is a measure of the likelihood of an event to occur. Among the mathematical skills, statistics and probability are of great help to the learners to develop critical thinking, data analysis, and decision-making skills. A probability is merely a number that reflects the chance or possibility or likelihood of an event to occur. The probability values can be expressed as proportions that range from 0 to 1 or as percentages ranging from 0 to 100. The basic rule to remember in all probability questions is this: the probability of an event happening is equal to the number of ways it can happen over total number of outcomes. The first problem is displayed on the screen. 3 fair cubical dice are thrown independently. What is the probability that all the dice read the same? Almost all of us are familiar with the shape and the configuration of a cubical dice. A cube has got 6 faces. So is a cubical dice with a number of dots impressed upon the faces. The total possibilities in the outcome when 3 such cubical dice are thrown is 216 ways, because after a throw the possibilities could be all having ones, or the first 2 having 1, the third one having 2, the first 2 having 1, the third having 3. Like that, the total sample space will amount to 216 ways. As per the asked question, the favorable cases of the dice showing the same face, that is all showing 1 or all showing 2 or all showing 6, is only 6 ways. Hence, as applying the basic rule of probability, we have the favored cases as 6 over the total number of cases 216. Simplification of the fraction gives 1 by 36 and forms the answer. Next problem is based on the concept of a median. Mean, median, and a mode are collectively known as the measures of central tendency and are mostly used in any statistical calculations of discrete data sets. We can calculate the median of data sets in 2 ways. If the data set is odd, that is containing odd number of elements, then arranging the data set either in ascending order or descending order and identifying the middle term will fetch us the median value. On the other hand, if the data set contains even number of elements, then the median will be the average value of the middle two terms. So with this basic background information about the median, read the problem. So 2 data sets A and B are given, each with 3 observations. But both data sets have the same median value. So in that context, which of the following statements must be true? And you are provided with 4 statements to check the correctness of them. To check the correctness of the given statements, let us approach the problems in the following way. Let the observations of a data set A be x1, x2 and x3. Also, let us assume that x1 less than x2 less than x3, and the observations of a data set B as y1, y2 and y3, and also let us assume that y1 less than y2 less than y3. Hence, the median of set A will be x2 and that of B will be y2. As per the problem statement, it is given that the medians of the two data sets are equal, that is x2 is equal to y2. In the combined data set, in possible ascending order, be x1 y1, x2 y2, x3 and y3. Since x2 is equal to y2, that is the only known information. Because of this, y1 should be less than x2 and y3 should be greater than x2. That is why this ascending order arrangement could be arrived. We can predict this ascending order with x2 and y2 as the middle elements because it is the only available information, but could not decide upon the positions of x1 and y1 and similarly that of x3 and y3. We do not know which one is big, either x1 or y1, and similarly x3 or y3. And moreover, this aspect is not needed to approach the that is verify the problem statements. Hence, after this possible arrangement based on the given information, the median of the combined data set can be obtained as x2 plus y2 by 2. Since it now contains even number of terms, median is the average of the middle two terms, that is x2 plus y2 by 2, and gives the answer as x2 or y2 because both are equal. Hence, among the given statements, statement in option 4 alone is valid. Remember, the other statement, the median of the combined data set is equal to median of B, would also be a true statement in the given problem situation. Look at this third one. In a buffet, 4 curries A, B, C and D were served. A guest was to eat any one or more than one curry, but not the combinations having C and D together. The number of available options for the guest we need to calculate. First, let us calculate the available options using the combinations calculation formula. That is NCR is equal to n factorial by r factorial into n minus r factorial. One out of the 4 curries can be tested by the guest in 4C1 ways, that is 4. Similarly, 2 out of them in 6 ways, that is 4C2 ways, 3 out of them in 4 ways, and 4 out of them in 1 way. Also recall the formula that probably all could have studied in the lower classes. 4C1 is equal to 4C3. That is why we get 4 in both the cases. But the detailed possibilities are tabulated for better understanding. By referring to the table, we see that the total tasting possibilities are 4 plus 6 plus 4 plus 1, that is 15 ways. Since the combo of curries C and D is not allowed, excluding the possibilities, we are left with 11 only. Hence, the answer is C, 11 options for tasting the curries. This one is also a similar problem which requires a critical thinking of the possible combinations. 3 girls having a ball each stand at the 3 corners of a triangle. Each of them throws their ball independently at random to one of the others once. The probability of no two friends throwing balls at each other is the thing to be calculated. Kindly refer to the guidance diagram where a triangle is drawn that the vertices G1, G2 and G3 denote the positions of the girls 1, 2 and 3. Each girl can throw the ball in two ways, that is either on the right hand side or on the left hand side. Suppose if G1 throws to G2 means that is through her left hand, and to G3 means it is through her right hand. So in one out of two ways she can throw the single ball that she possesses. The same argument can be extended for G2 and G3. So the throw pattern could be in 1 by 2 into 1 by 2 into 1 by 2, that is 1 out of 8 ways. But it is specifically mentioned in the problem statement that no girl should throw the ball towards each other. So to arrive this, let us first list out the throwing possibilities, which are 8 in number. G1, G2, G3 denotes the girls, and L denotes left hand throw, and R denotes right hand throw. So we have the combinations from L to R. Out of this, applying the condition, we are left with only the two options, namely L or R. Only in these combinations, the throw rule will be faithfully followed. Therefore, the probability is 2 over 8, which is equal to 1 by 4. This one is the final problem statement in this video. In a job interview, out of the 17 applicants, there are 8 men and 9 women. 2 persons are to be selected for the job. Find the probability that at least one of the selected persons will be a woman. Given that the number of applications are from 8 men and 9 women, the selection event as per the requirement can be done in these 3 possible ways. That is, first selecting a woman followed by a man, or first selecting a man followed by a woman, or both the selections being women. These 3 selection patterns can be regarded as mutually exclusive events. That is, the probability of occurrence of one case will not affect the other. So the overall probabilities of selection will be the sum of the probabilities of these 3 patterns or possibilities. Hence, the required probability is 9 by 17 into 8 by 16 plus 8 by 17 into 9 by 16 plus 9 by 17 into 8 by 16. The meaning is 9 men. Suppose if the first selection is a woman, she can be selected in 9 out of 17 ways. Once it is done, the total reduces to 16. Therefore, the second applicant, that is a male or man, can be selected in 8 out of 16 ways. Hence, the probability is 9 by 17 into 8 by 16 for the first selection pattern. Similarly, the figure is 8 by 17 into 9 by 16 for the second pattern, and 9 by 17 into 8 by 16 for the third pattern. Overall probability is sum of these 3 fractions, 9 by 34 plus 9 by 34 plus 9 by 34, giving rise to 27 by 34, and forms the answer. So viewers, I hope all of you have enjoyed these probability based problems and got some interesting solution patterns. Let me meet you again in some other video with similar problems. Thank you.